Welcome to another topic on unsymmetrical bending. This is a problem on second case, that is section is unsymmetrical and the load is along any centroidal axis. As an example, we have been talking about the angle section from the start beginning of the topic. For example, these are the centroidal axis x and y. So if the load is along y axis, for example, the load is acting here, then as the section is unsymmetric, then the load is not very symmetric. The load is also unsymmetric. So as per this, I can create a new set of axes. So how it is bending? It's with reference to new set of axes u and v. Those axes are known as principal axes. We need to find out at which angle these are located. We need to look at the principal axis and then we have to continue to find out the stresses. Let us get into that. We have already initially seen two cases. One is section is symmetric and load line is along the parallel load line along or parallel to the centroidal axis. Examples are I section and rectangular section. And in the second case, we have seen the angle section. We are taking the angle section which has the section unsymmetric and load is along the centroidal axis. We are taking that load along the y-axis in the problem we are doing it now. Okay. Let me read the question now. A cantilever of length 1 meter carries a point load of 2000 Newton at the free end. The cross section of the cantilever is unequal angle of dimensions 100 mm by 60 mm and 10 mm thick. They will not give you the diagram in the question. Okay, and they have given you the clue. The small leg of the angle is horizontal. The load passes through the centroid of the section. Determine position of the neutral axis, magnitude of the maximum stresses set up at the fixed section of the cantilever. This is how they have given to us, right? So let us see the diagram what we have. And one more thing you have to remember, whenever the angle section is given, whether they mention or not, the shorter leg you always take it horizontally, so that will be very easy for calculation. Otherwise you will get uh, uh, weird answers for moment of inertia when you calculate. So let me take as per the instructions given. So here and one data, according to the data we have, the length is 1 meter. So let me say that is 1000 mm and the load is given as 2000 Newton. And look at the question carefully. This is a cantilever of length. This is the cantilever beam. And initially I have shown the diagram which is the cantilever. This is the same topic we are discussing here. After bending, it will look like this. Okay, this is the cantilever. So whatever the load applied on the free end of the cantilever, where is the maximum bending moment? At fixed section, right? Fixed part. So the maximum bending moment at fixed end will be force multiplied by distance up to the fixed end, that is W into L. So what is W? We have 2000 and length we have 1000. So ultimately that is 2 into 10 power 6 Newton mm. So that is what we have. Before that, what they are asking us to find out neutral axis. Before locating neutral axis, when you apply the load, it will twist as I have shown you in the diagram. So according to the principle, we have to locate the principal axis. We have to, that means how much angle is there between the principal axis and centroidal axis. We need to locate the principal axis first. So let us do it. Look, in order to locate the principal axis, what we need to have. So in the previous, while talking about principal moments of inertia, I have told you we need to have moment of inertia about centroidal axis, that is Ixx, Iyy, and product of inertia Ixy. If we have these three, we can find out the location of principal axis and the value magnitude of the principal axis. So let us try to find out these all. So for that, we need to divide this into two parts, two rectangles. No, this angle section into two parts. So let me divide. This is first, this is second, and we have the dimensions as this is 60 mm and this leg is total 100 mm and this is 10 mm. This is also 10 mm as given in the question. I have not mentioned in the previous slide, but here you need it, so I am mentioning it. So 90 mm. Okay, now in order to find out moments of inertia, again we need to have the centroidal axis location, the coordinates of x and y. We need to find out x bar and y bar. Let me find out, after separating, let me take what is B1 here, 60 mm. D1 we have 10 mm. B2 we have 10 mm. This is B2. Okay. D2 we have depth for the rectangle 2 is 90 mm from the diagram. As you know it, I have written them directly. So area 1 will be 60 into 10, that will be 600 mm square, breadth into depth. And area 2 will be 10 into 90, that will be 900 mm square. So now you can find out what is the x coordinate for rectangle 1. So x1 will be half of the horizontal distance of the first rectangle, that is half of b1, that is 60 by 2, that is 30 mm. And x2, sorry, y1 will be d1 by 2, this is d1, that is 10 by 2, 5 mm. And x2 value will be, this is x2, yes, this is x2, so that x2 is 10 by 2, that is d2 by 2, 5 mm. And y2 will be, now it is attached to the first rectangle, so I would say that is d1 plus d2 by 2, that is 10 plus 90 by 2, that is 55 mm. Now we can find out the x coordinate. X bar is equal to a1 x1 plus a2 x2 by a1 plus a2. Similarly, y bar is equal to a1 y1 plus a2 y2 by a1 plus a2. So if you substitute whatever all the parameters are available here, if you just substitute them, a1 are available, x1 x2 y1 y2 are all available, so you can easily find out the values of x bar and y bar. So if you calculate, substitute and calculate, you will get x bar as 15 mm and y bar as 35 mm. So the entire this calculation was very clear in the notes, you can download it. So later let us find out the value of moment of inertia about x-axis. So Ixx, let me find out, that is moment of inertia of rectangle 1 plus rectangle 2. Okay, that is b1 d1 cube by 12 plus a1 into y bar minus y1 whole square plus b2 d2 cube by 12 plus a2 into y bar minus y2 whole square. So if you substitute whatever the parameters you have in the slide, then you will get the value of Ixx as 1512, just a minute, 15125 00 mm power 4. If you substitute all of them, all are available here, what I have written there. So entire the calculation was clear in the notes, you can refer it. Then moment of inertia about y-axis will be d1 b1 cube by 12 plus a1 into y bar minus y2 whole, sorry, yes, y bar minus y1 whole square, sorry, just a minute, this is x bar minus x1 whole square, and plus d2 b2 cube by 12 plus a2 into x bar minus x2 whole square. So again, if you substitute all the parameters, then you will get the moment of inertia about y-axis as 412500 mm power 4. And you need to find out product of inertia. Product of inertia, that is very very important, you have to look at it carefully. If you attend my last session to finding out principal moment of inertia for the angle section, the problem, you will understand it very clearly. Okay, let me have this. I may need to use more colors in order to make you understand here. Please bear with me, it may take time. So what are the values we have? This is 15 mm, that is x bar. So all dimensions are in mm, I'm not mentioning dimensions here. This is y bar 35. Okay, those are okay. Now you have another new set of axes, so let me draw them here. This is, you have y1, okay, and this is x1. X1 is how much? X1 is, we have 30 mm, that is half of 60. Okay, this is 15, this is 30, and this y1 is 5. Okay, now another set of axes here. This is x2. X2 value will be how much? This is 5. X2 value is 5, and y2 value will be half of this, sorry, by coordinate, that is 55 mm. So you need to find out the distances. uh, just a minute. Okay. So okay, IXY is actually area 1 multiplied by, sorry, not x, a1 b1 plus a2 into small a2 small b2. So let us find out what are a1 and b1 here. So if you have x axis and y axis over here, so the difference of this x bar x1 minus x bar, so this difference is a1. So that is how much? 30 minus 15, that is 15 mm. And if you see, it is going right, it going right, so it is positive. So let me write it here, a1 is positive 15 mm. And b1, so b1 is, so this y bar minus y1, so this is also above the axis, that is how much, this distance we have to consider. This is 35 minus 5, that is 30 mm. That is b, that is also positive, that is going up. So b1 is also positive 30 mm. Now what is a2? So a2 is the horizontal distance from x bar and horizontal distance from this x bar to x2. So that is this gap. So this is x bar minus x2. So this distance we need, that is a2. That is 15 minus 5, 10. That is negative. So if you see, this is left of the section, so that is negative. Just like our coordinate system, that is minus, the minus how much? 10 mm. And b2 is, so this is y2, this is y bar. The distance between these two will be b2. That is how much? 55 minus 35, 20. So b2 will be 20. Is it positive or negative? As this is below the coordinate axis, that will be negative. B2 will be negative 20 mm. So let us use them now. Area 1 we have 600, and A1 let me substitute 15, into B1 we have 30, plus A2 we have 900, and A2 means area here. Small a2 is minus 10 and small b2 is minus 20. So if you do that, we'll get the answer as 450,000 mm power 4. So we got these all inputs in order to find out the principal moments of inertia. Let us now calculate them. Principal moments of inertia, IUU, you have these values, you have two methods to calculate. So IUU is equal to IXX plus IYY by 2 plus under root IXX minus IYY by 2 whole square plus IXY whole square. So if you find out that, you will get IUU, IVV, you will get it as the same formula, but what you have to put it as negative here, negative sign. This minus this will give you IVV, right? So after getting these two, let me locate the principal axis. So if you remember, we have tan 2 theta is equal to minus 2 IXY by IXX minus IYY. So let me substitute what are the values we have. IXY we have 4540 by IXX we have 15. I don't remember very correctly. It may seems 15,125,00 minus 4125,00. So we will get it as minus 0.818. That is tan 2 theta value. Now if you want to have 2 theta value, that will be tan inverse minus 0.818. So if you do that, you will get it as minus 39.28. So that is nothing but this tan theta will be negative in second quadrant. So 180 minus 39.28. You will get it as 140.72. That will be 2 theta. Theta will be 140.72 by 2. That will be 70.36 degrees. So at 70.36 degrees, now our new principal axes are located. So let me talk about. So actually we need to find out first location of principal axis, then we have to find out IUU and IVV. Okay, this is 70.36. Now this is IUU, sorry, UU, and this is perpendicular to that will be VV. this is x, this is y. Right, we have now located the principal axis, we have found the moments of inertia about principal axis. So that is small part is over. In order to look at now we need to see the main part, what was given in the question, neutral axis we need to find out. Just a minute, I'm unable to change the color. Okay, okay, now position of neutral axis we need to find out. Position of neutral axis, yes. We have positioned the principal axis before that, now we are locating neutral axis. So for that we need we have if you remember, we have these formulas, and the load is in this way. These are the principal axis for this principal axis. If you remember, we have this will be m where it is acting, and we need to take them with respect to the new axis. That means along this line, so when this is moment or load, it is acting at the exactly along the axis, right? Y axis, along the y axis it is acting. So it is y m, and for this is u and vv. And for vv, if you remember, this is 70.36 degrees, this is also 70.36 degrees. You can take any of the triangle and you can make it as a right angle triangle, and this mv will be m cos theta, and this will be m sin theta. Sorry, this is m sin theta and this is okay, let me show it here. So this is 70.36 degrees, so this is mv, let me say this is m, and this is mu. So opposite side will be sine, right? So mu will be m sin theta, opposite side by adjacent side. So mv will be adjacent side by hypotenuse, that will be m cos theta. So let me write it here directly. Sigma is equal to, we have m cos theta, m cos theta by iuu into v, and this is m sin theta by ivv into u. Here m's cos, this is m sin theta, this is trying to bend this about v axis, so we have to consider moment of inertia about v axis. And similarly for cos theta, this was already discussed in the previous videos, you can see that. So moment we have 2 into 10 power 6 into, and cos theta cos 70.36 by iuu we have 251905.6, as you have calculated from the previous formula I have given to you. If you substitute, you will get iuu value this, and 2 into 10 power 6 into sine 70.36 by ivv value we have 1673094 into u. So keep uv and u as it is. Okay, now that will be 1.126u plus 2.67v if you simplify that. And for neutral, what is criteria for neutral axis? Stress will be zero. Stress will be zero at the neutral axis. That is the main criteria you have to remember. So 1.126 u plus 2.67 v will be zero. So ultimately you will get it as 1 point v, you can write it as minus 4 point. If you simplify that, you will get it as 42656 times u. So that is in the form of y is equal to mx. So v is equal to mu, let me say. So that means m is minus 4256. That is nothing but m is slope. Let me say m is equal to tan theta is equal to minus 4256. So theta is equal to now tan inverse minus 4256. That will be, so ultimately you will get the angle as minus 23.054. That means, okay, that means we have uh, okay, as we got the neutral axis position, let me locate it. So initially we have these principal axis uu and vv. Let me put the points, this is x, this is y. and new neutral axis we have at 70 point at 70. This is passing through the centroid place. This is 70.36 u u and v v. So if you look at the neutral axis, that is located minus 23 degrees. That means, so if it is plus 23 degrees, you have to go beyond that, go above. If it is minus 23, you have to go below. So that means it is locating here. Neutral axis is located here from the axis u. Because above the principal axis we are locating, this will be 23 point, yes, 23 degrees, minus 23 degrees. That is neutral axis. I hope you have understood. Everything is very clear in the notes. If you have this explanation on notes, you will understand it very better. And again, we have the values of principal coordinates. U is equal to, so x dash, y dash. Let me write them as u and y. X cos theta plus y sin theta. And v is equal to y cos theta minus x sin theta. These are the coordinates we have. We need to find out now stresses at points. We need to find out maximum stresses, maximum compressive and maximum tensile stresses. So let me take, this is, if you consider this UU or neutral axis, if you consider, so if you consider all the points in this above neutral axis, this is the farthest, the far point this is. So this is where you will get maximum tensile stress. Why I am saying tensile? For this cantilever, if you bend it like this, above layers will be under tension, below layers will be under compression. So you try it with your hand. So when you are bending your hand, you can see all the top skin of your hand will be elongated, and below the skin layer will be compressed. Similarly for this cantilever, you can think like that, and the top layers will be under tension, bottom layers will be under compression. So let me say this point L where you will get maximum tensile stress. Right. So because sigma is equal to m by I into y, where y is the distance from the neutral axis, what we have already seen. That is, as the distance y increases, the stress will also increase. So we need to find out maximum stress. We have to take maximum distance. So if you consider all the points above neutral axis, all the corner points, this is very near to this, and this is the farthest point, farthest point, and this is bottom. You can see this is, which distance is more at this point or this point. This is point is locating at a lot, at far distance. So let me say point M, where you will get maximum tensile stresses at L, where you will get maximum compressive stresses at N. So let us now find out uh, at point L. At point L, so x bar we have to take. So similar to this, x bar we have to consider, that is how much, minus x, the distance from the neutral axis we are taking, so simply from this point. Just we are now calculating x bar, not u. Refers the distance up to this is u, and if we consider from x, that will be x bar. Remember that, please don't get confused. So that will be minus 15 m. Why it is minus? So if you, with respect to our old coordinates, that is left of the section, that is negative, and y bar will be plus y bar, y will be plus y or minus y. This is above the coordinate axis, that will be plus y. That is how much? Y bar we have 35 mm. So from this, let us find out u and v. U is equal to u. If you find out the value of u, you will get distance from the neutral axis newly obtained. Okay, that will be u is equal to x cos theta plus y sin theta. So you have this values of x and theta value, we have 70.36. If you substitute all of them, you will find out you will get the value of u as 27.93, and v will be y cos theta minus x sin theta. And in the place of theta, you have to substitute 70.36, and x and y values as I have given. If you substitute them, you will get 25.89 mm. Now resultant bending stress at point L will be, initially we have that equation, right? 1.126 u plus 2.67 v. In the place of u and v, substitute these two. So you will get it as 100.112 Newton per mm square. In a similar manner, you have to find out at point M. So let me find it here itself. At point M, what happens? So you have to find out x bar and y bar for point M. So x value will be x bar. X value will be how much? Not simply x bar. So you have to take the distance here up to here. That means x bar minus this. That is how much? X bar minus this is how much? 10 mm it seems. And this is negative. Why? It is left side of the coordinate system. For coordinate system, this part is negative for x, right? So in a similar manner, let me take minus x bar minus 10. That will be minus of 15 minus 10. That is minus 5. Okay, now y bar will be, so only finding x bar and y bar you may confuse. Remaining all are substitution. You will do it very simply. Y bar will be, now y bar, this point we need to find out. So the entire distance is how much? This is 100, right? And you need to find out this value. 100 minus this y bar gives you this value. That is how much? Minus of, because why I am taking minus is because this is below the coordinate axis. Okay, y as comes down it will be negative, right? So that is why I am taking y bar negative. So y will be 100 minus y bar 35. So if you do that, 100 minus y bar, you will get the distance up to here. That will be minus 65. So it is very clearly given in the notes. Only for the explanation part, please see here. Or you can download the notes. If you could not understand, download the notes, keep the notes with you and see the video, then you will understand. Okay, then you can find out the value of u. Again, substitute the value here, x cos theta plus y sin theta, and again theta is 70.36 degrees, and x and y values, new values we have given, we have obtained 5 and 65. If you substitute the values here, you will get u value will be minus 62.91, b value will be 17.13. In the same manner you have to do. And resulting bending stress will be, that is how much in the 1.126 u plus, in the same formula we have to substitute, plus 2.67 b. So with this you got the values of u and b. Just to substitute here, we'll get it as minus 116.35. This negative is compression here. Don't get stereotype as negative will be always compressive or positive will be always tensile. According to the situation, I can change whatever, but only thing is, if you consider compressive as negative, you have to consider tensile as positive. If you consider tensile as negative, you have to consider compressive stress as negative. So the only criteria you have to remember that. So in the previous videos we have taken tensile stress as negative, and here we are taking it as positive. So there we have done for simply supported beam, here we are doing for cantilever beam. So according to my convenience I have taken it as positive. So this will be positive, and this is tensile stress, because for uh, cantilever beam, tensile stress will be developed at the top of the top layer of the section, right? You might have already studied in your previous semester. If you have any that itself what we have to find out. This is the maximum tensile stress, 100.112. Maximum compression, we got it as minus 116.35. That is the result. So no need to find out all at other points. So if you do this problem, you will understand it better. So you please practice this. I hope you have understood that problem. If not, see that again, see the notes. If you still could not understand, please let me know. And do practice this question, you will get doubts. If you get the doubts, immediately contact me. Okay, so this is the homework problem I am giving to you. The simply supported beam of span 3 meter carries a load of 500 newton at its center. The section below the beam is unequal of size 100 mm by 100 mm, 100 mm by 100 mm, and 12.5 mm thick, as shown in the figure below. Okay, this is the figure they have given to you. Same angle section, but only direction is different. This is 12.5 is thickness. Equal angle section, this is What we have done previously is unequal angle section. Equal 100 by 100, right? So it is equal angle. The load line passes through the centroid G and along the line YY. Determine the stresses at the points A, B, C. So A, this is point A, this is point B, and this is point C. Of the midsection of the beam. Now deflection of the beam at the midsection position of the neutral axis. Take E is equal to 2 into 10 power 5 Newton per mm square. Now, what I have given the beam is simply supported. Please remember, previously I have done this that as cantilever. Now you are doing simply supported. Please understand all the signs, all the processes may be changed. Process means here uh, process of taking moment and all. And the problem doing is similar to previous problem what I have solved. Please do it. If you have any doubt, please let me know. Better you practice it now. Later you may forget the process. Thanks for watching. If you have any doubt, please contact me and do the problem. Send it to my mail. I'm very happy to solve your doubts and evaluate your answers. medurimonica@gmail.com. Anybody can send me the mail. Thank you. Thanks for watching.